Lecture 4. Lecture name: The natural gas composition of the atmospheric air, its influence on the health, atmospheric air pollution and disease among population, information about toxic fog, sanitary bacteriological parameter of atmospheric air, modern ecological problem, and main principle protection of atmospheric air. Among the parameters of environment which permanently influence of human organism, the air is the most important. The human organism survives without food 70 days, without water 7 days, without air just several minutes. Air represents the mechanical mix of gases consisting of oxygen equal 20.93%, nitrogen 71.1%, carbonic gas 0.03, 0.04%, and group of inert gases about 1%. In an atmosphere occurs constant circulation of gases. The person and animals at breath absorb oxygen and breathe out the carbon dioxide. The same process occurs at any oxidizing process: burning, decay, rotting. The vegetative cover of a terrestrial surface absorbs carbonic acid and allocates oxygen. This process each other counterbalanced long time, therefore constancy of structure of the air environment, to which promoted the moving of air weight, providing uniform hushing of air was kept. It's necessary to note that the chemical compounds of air varies depending on height of an air layer a little. So, at height of 28 km, air contains 20.39% of oxygen. On sea level, 90.93%. During a day in condition of complete rest, the adult man passes through lungs 13-14 cubic meters of air. It is significant volume increasing at physical activity. Oxygen, equal to 20.96%, is the most important gas of air for vital function. It's used up for oxidizing process in organism. It's summed through lungs in blood and is delivered to organism cells and tissue as a part of oxyhemoglobin. And the natural oxygen also is necessary for oxidation of organic substance in water, air, and soil, and also to keep up burning process. The source of oxygen in the plants, green plants, we form oxygen under the action of solar radiation in the process of photosynthesis and throughout in air during breath. Green plants form a large amount of oxygen, and owing to permanent mixing of atmospheric layer, the concentration of oxygen is practically stable, around 21%. The low concentration of oxygen is absorbed and released to a high and hermetically sealed room in the emergency condition. The high concentration of oxygen is absorbed in condition of high atmospheric pressure, in cation condition. At partial pressure over 600 mm mercury point, the oxygen can be toxic substance, causing pulmonary edema and pneumonia. There is a dynamic isomer of oxygen, free nuclear oxygen, the ozone, in the atmosphere, which is the strongest oxidizer. Its form is natural under the influence of short-wave ultraviolet radiation of the sun, at lengthening exchange during evaporation of water. Ozone has a major role in protection of biological objects of planet against a destructive influence of hard ultraviolet. Also, ozone holds back in a stratosphere at height of 20-30 km. Ozone has origin pleasant smell of freshness. The ozone presence can be found out easily in woods after a thunderstorm, also in mountains and in a pure environment. is considered as a parameter of air purity. However, the excess of ozone is adverse for vital function of organism, and since concentration of 0.1 mg per meter, it works as irritating gas. The ozone present at the air of the big industrial city, polluted by emission of transport and industrial objects, is considered as unfavorable signal because even such condition the ozone is formed as a result of photochemical reaction and smoke formation. High oxidizing activity of ozone is used at water disinfection. In air, it is a little carbonic gas. In atmospheric air is only 0.03–0.04% of carbonic gas. However, it has very big hygienic value. First of all, it's necessary to note its role in maintenance of ecological equilibrium of an environment on a global scale. For a long time, the oxidizing and regenerative process occurring in the natural, mutually each other counterbalanced by virtue of that the structure of air practically did not vary. However, in connection with the technical progress, sharply increasing amount of engines of internal combustion and other power installation, the quantity of oxidizing process on globe has considerably increased. At the same time, as a result of urbanization and development of the industry, the amount of the green planting being the basic consumes of carbonic acid has substantially decreased. Last year, growth of concentration of carbonic acid was outlined in atmospheric air. Scientists considered that if increase of the quantity of carbonic acid in air will occur and further in the natural, there can be so-called hotbed effect at the carbonic acid which is taking place in an atmosphere, retains a long-wave part of infrared radiation radiated from a terrestrial surface to a space. In result where will be an increase of mid-annual temperature of atmospheric air that will lead to a thriving of polar glaciers, increase of a level of world ocean, and consequently to flooding a significant part of a terrestrial surface. For air of premises, the content of carbonic gas has sanitary indicative value. In premises where there are people, in air various product of live activity of human body act. The exhaled air set with carbonic acid and water pairs, evaporation from a surface of skin and mucous membrane of respiratory ways in structure of which were a product of decomposition of slim, sweet skin fat. In result in air concentration of carbonic acid increase, there are ammonia, aldehydes, ketones, and other badly smelling gases, increasing humidity, dust, and microbe impurity of air. That as a whole, air is characterized as stuffy, vain, influencing on the state of health, serviceability, and health of people. On concentration of carbonic acid in such air, it's possible to define a degree of its general impurity. Therefore, carbonic gas serves as a sanitary parameter of cleanliness of air in inhabited and public premises. Air is considered fresh if concentration of carbonic acid does not exceed 0.1%. This also is considered maximum permissible for air in inhabited and public premises. Besides, it's necessary to take into account that factor that carbonic gas is heavy than air and can accumulate in the bottom parts of the closed space, not expose intensive ventilation. Most important, it for those places where there are increased oxidizing process. The ferment stops, the disturbed means or wells at the bottom of which are decaying or wandered sewages. In such place, the concentration of carbonic acid can reach the big size and represent hazard to the health and existence of a person. If the concentration of carbonic gas in inhaled air exceeds 3%, existence in such atmosphere becomes dangerous to health. Concentration of carbonic gas above 10% is considered dangerous to a life. Loss of consciousness comes in some minutes of breathing by such air. At concentration of 20%, there is a paralysis of the respiratory center within several seconds. Nitrogen comes to 78.1% and mixes the oxygen. Nitrogen does not maintain the respiration and burning process. Its concentration in air is permanent and equal in inspired and expired air. In conditions of the high atmospheric pressure, the nitrogen has narcotic effect and is also now its role in pathogenesis of casein disease. The nitrogen circulation in the natural is carried out by means of certain kind of soil microflora, plants and animals, and also with the help of electrical discharge in atmosphere. Therefore, the nitrogen is combined to biological object and then it again turns to the atmosphere. Neon, helium, xenon, radon, argon, krypton are the inert gases. They have not a direct physiological meaning. The structure of the air environment constantly includes the various extraneous inclusion getting in from various sources. Eventually is the result of the activity of the person directed on development of technical progress, the amount of such extraneous impurity to the air environment increase. Now, so-called clean air in settlement can be shown only as an exhibit. What is pollution and what are pollutants? What is pollution? Pollution is an undesirable change in the physical, chemical, or biological characteristic of air, water, and soil that may harmfully affect the life or create a potential health hazard of any living organism. Pollution is the best direct or indirect change in any component of the biosphere that is harmful to the living components, and in particular indescribable for man, affecting adversely the industrial progress, cultural and natural assets on general environment. But what are pollutants? Pollutants, any substance which causes pollution is called a pollutant. A pollutant may thus include any chemical or geochemical, for example, dust, sediment, substance, biotic component or its product, or physical factor, for example, heat that is released intentionally by man into the environment in such a concentration that may have adverse, harmful, or unpleasant effect. Environmental pollutant, deposited matter, gases, acid droplets, fluorides, metal, agrochemicals, photochemical oxidants, solid waste, noise, and others. Perhaps what is common in all of this definition is the ability of the environment to absorb and adapt to change brought about by human activity. In one word, environmental pollution takes place when the environment cannot process and neutralize harmful byproduct of human activity. For example, poisonous gas emission in due course without any structural or functional damage to its system. Pollution occurs on the one hand because the natural environment does not know how to decompose the amateurly generated element, and on the other, there is a lack of knowledge on the part of humans on how to decompose these pollutants artificially. Also, pollution had been known to exist for a very long time. At least since people started using 5,000 of years ago. It had seen the growth of truly global proportion early since the onset of the Industrial Revolution during the 9th century. The Industrial Revolution brought with it technological progress such as discovery of oil and its virtually universal use for different industries. Technological progress facilitated by super efficiency of capitalism business practice, division of labor, chapter production costs, overproduction, overconsumption, overpollution had probably become one of the main causes of serious deterioration of natural resources. At the same time, of course, development of natural science led to a better understanding of negative effects produced by pollution of the environment. Environmental pollution is a problem both in development and developing countries. There are two kinds of sources of air pollution: natural and artificial. Natural pollution of air by dust storms, volcanoes, forest fires; artificial or anthropogenic, industrial enterprises, motor transport, agricultural, economic household, trash burning, thermoelectric power station, rocket cosmic technique, and others. Air pollution results from gases emission from mainly industry, thermal power station, automobiles, domestic combustion. Industrial chemist waste were a number of industries which are source of air pollution. Petroleum refineries are the major source of gases pollution. Food and fertilizer industries which emit gases pollution. Chemical manufacturing industries which emit acid vapors in air. Thermal power station. There are a number of thermal power station and superthermal power station in the country. The National Thermal Power Corporation is setting up for Mammoth coal power station to augment the energy generation. The coal consumption of thermal plants is several million tons. The chief pollutants are fly ash, sulfate oxygen, and other gases and hydrocarbons. Automobiles, widely distributed in modern cities, is the basic source of air pollution by oxides of carbon. Besides transport throughout in air, there is oxides of nitrogen, dioxide of carbon, and burned down hydrocarbon, ozone, and other gases. Diesel engines throughout in air also soot, and the engines using is as fuel gasoline, a significant amount of lead. Every working engine of the car usually throw out in air about 3 cubic meters of pure oxides of carbon at 1 o'clock, and trucks it's twice more. The number of motor transport constantly grows, and now the quantity of automobiles in the world is comparable to quantity of the population. As a result of it in air of large city with intensive automobile movement, concentration of oxides of carbon considerably exceeds maximum permissible norm. Liquid pollution is formed in air mainly due to interaction of gases pollution with atmospheric motion. In result, for example, from sulfurous gas throughout in air by power system, from the acid-containing sulfur, which then drop out of an atmosphere as so-called acid rain. Now, all taken together, pollution of the air environment reach in many causes of such high concentration which represent health hazard and lives of people. High degrees of pollution over atmosphere can be named now toxic fog or smokes. Such smokes formerly happened rather seldom and only in some cities distinguished by characteristic weather conditions. The matter is that weather conditions play an essential role in occurring such toxic fog. The last are formed usually at some combination of meteorological factors. At low overcast, presence of temperature inversion, a full calm. At such confluence of meteorological conditions, pollution enters in air are not carried by a wind, are not diluted and concentrated at the surface of the ground. Earlier, classical city where this folk London was however last year the geography of the occurrence has sharply extended. The degree of impurity of air substantially depends on various conditions. From a season, it's more in the winter than in the summer because heating systems are included. From time of day, maximum in the morning, minimum at night. From velocity and direction of a wind, dilatation. From a vertical gradient of temperature, temperature inversion. From a degree of humidity of air. Fogs promote concentration of pollution. From frequency and amount of an atmospheric precipitation. From distance in relation to source of emission. Source of air pollution also divides on the point source and non-point source. Point source is a single identifiable source of air, water, thermal, noise or light pollution, for example water pollution, thermal pollution, industrial point source of air pollution. Non-point source pollution refers to both water and air pollution from diffuse source. Non-point source water pollution affect a water body from source such as polluted runoff from agricultural areas draining into a river or windborne debris blowing out to sea. Area source are source of pollution which emit a substance or radiation from a specific area, local, regional, global. Line source, a source of air, noise, water contamination, or electromagnetic radiation that emanates from a linear, one-dimensional geometry. The most prominent linear sources are roadway air pollution, aircraft air emission, roadway noise. Volume source of pollution are a three-dimensional source of pollutant emission. Examples of a volume source of pollution are dust emission from the wind erosion of uncovered gravel pills, sand pills, limestone pills, coal pills. Air pollutants divided two groups, primary and secondary. The 5 primary criteria pollutants include the gases carbon monoxide, nitrogen oxide, sulfur dioxide, and solid or liquid particulates smaller than 10 nanometer, and particulate lead. Sulfur dioxide has been a serious problem in air pollution since the earliest days of industrialization. It has been the major problem in reducing or achieving air pollution during the period of rapid economic growth in many countries. It was one of the major components of a so-called London fog, which had serious direct health effects. Soon after the London fog incident, experimental study of the effect of sulfur dioxide on humans showed that at least in acute exposure concentration of up to 8 cause respiratory change that were dose dependent. A later study revealed that the main effect of sulfur dioxide is bronchoconstriction, clogging our airways, causing increased resistance to breathing, which is dose-dependent, rapid, and tends to peak at 10 minutes. Persons with asthma are particularly susceptible, and in fact, asthmatics suffer more from the effect of sulfur dioxide than does the general public. Sulfate, a major sulfur-containing ion in water, is a major constituent of air pollution capable of forming acid. Sulfate itself appears to trigger bronchoconstriction in persons with vulnerable airways and is a major constituent of ultrafine particles. There are other acid ingredients in air pollution, such as nitric acid, but less is known about them. From their emission into the air by industry and motor vessels, these acids cause a phenomenon known as acid rain. Because of the small size of acid-forming aerosols such as sulfur dioxide, sulfates, and nitrogen dioxide, and their tendency to ride along of particles, this aerosol can deposit deeply in the distal lung and airspace. Combined with ozone, they appear to provoke airways responses in an additive or synergetic manner. They have also been implicated in causing mortality in association with anthracene particles. Oxide of nitrogen is maintained above nitrogen compounds, especially nitrogen dioxide, are involved in the formation of ozone at ground level. The oxides of nitrogen also produce adverse health effects and are important air pollutants in their own right. Nitric oxide is produced by combustion. Nitrogen dioxide, which has greater health effects, is a secondary pollutant created by the oxidation of nitric oxide under conditions of sunlight, or it may be formed directly by high-temperature combustion in power plants or indoor from gas stoves. The direct effects of nitric oxide include increased incidence of infection, lower respiratory disease in children, and increased asthmatic problems. Extensive studies on the oxides of nitrogen have shown that they cause deafness in the respiratory tract, the incidence and severity of bacterial infection, the exposure. They have a marked effect using the capacity of the lung to clear fatigue and bacteria. Nitric dioxide from bronchoconstriction and asthma in much the same way as ozone, but is less potent than ozone in causing asthmatic effect. Despite the case of researchers, the full effect of oxide of nitrogen are not known. Known from health effect. Other effects are known but difficult to evaluate. Carbon monoxide is produced primarily by the incomplete burning of fossil fuels, for example, by car and other gasoline-powered engines and by car, coal, or oil heaters. As it is odorless, colorless, and slightly heavier than air, it tends to collect its confined space and affect people without warming. The written history of carbon monoxide goes back centuries, as Roman records discuss this associated with fires in enclosed spaces. Basically, as carbon monoxide concentration goes up, the oxygen carrying capacity of the blood goes down because oxygen molecules are literally being replaced by carbon monoxide molecules and the ability of the hemoglobin, carboxyl hemoglobin, to bind oxygen depends on oxygen binding at near boring cities. The carbon monoxide molecules bound to hemoglobin is 200-300 times stronger than the hemoglobin-oxygen bond. So, carbon monoxide is not cleared easily from the circulatory system. Exposure to short period of high concentration carbon monoxide is just as bad as long period of low concentration. Carbon monoxide is also a messenger molecule in the human nervous system, and some of its effects may be direct. The carboxyl hemoglobin blocks the process of oxygen transportation to tissue. So the acute and chronic anoxemia, it depends on carbon monoxide concentration, is developed in organism. The chronic anoxemia is prevalent at concentration 20-30 mg per meter. Its symptoms are headache, impairment of memory, sleep disorders, fatigue. Normal amounts of carbon monoxide in the blood are in the range of 1%. Smokers can have high concentration, around 3-5%, and if one were to exercise at rush hour in heavy traffic at 10-15, level of free fall could be expected. Different laws observed adverse effect health levels. Exercise tolerance does not seem to be decreased until after a level of about 5% is reached in healthy subjects. People at increased risk include those with heart and lung disease. Trace metals. The trace metals include cadmium, mercury, zinc, copper, lead, and a dozen others. They are called trace metals because they are present in the environment or body only in small amounts. Human activity has led to an increase in the release of this element into the environment. Trace metals may have direct health effects on the nervous and respiratory system, such as the liver and skin. Lead is the best study of this trace metal. It's known to be a high toxic substance that particularly causes nerve damage. In children, this can result in learning disability and neurobehavioral problems. An estimate 18-90% of lead in ambient air is thought to be derived from the combustion of leaded petrol. Because of this effect on the behavior and learning ability of children, even at low level of exposure, efforts from the world are being directed at removing lead from gasoline and consumer products such as a house paint. The World Health Organization quantities value for long-term exposure to lead in the air is 0.51 milligram per meter year. Other trace metals that occur in air pollution include mercury, vanadium, and iron, all at very low concentration. This table includes information about air quality in the different cities and contains is this air, sulfur dioxide, suspended particulate matter, lead, carbon monoxide concentration. Respiratory symptoms are the most common adverse health effects from air pollution. Common symptoms include cough, which may produce sputum, nose and throat irritation, and mid-shortness of breath. The respiratory symptoms are often associated with eye irritation and a sense of fatigue. Exacerbation of allergic symptoms is typical. People with bronchitis may also experience more coughing due to increased irritation of the bronchial mucosa. Acute upper and lower respiratory tract infection also appear to occur more frequently in residents or areas with high pollution level. Fever is not a feature of air pollution exposure alone and suggests a possible infection. Direct cardiovascular effects of air pollution are associated primarily with carbon monoxide, which is known to reduce oxygen delivery to the myocardium and suspected to aggravate the process of atherosclerosis. This effect may occur in normal individuals who have to unusual susceptibility, while they are particularly severe among people with existing heart disease. Respiratory effect of air pollution, particularly in people who suffer from chronic bronchitis, may place an additional strain on the heart as well. Air pollution is associated with increased risk of death from heart disease and lung disease, even at a level below that's known to be acutely toxic to the lung or heart. The stimulation of nerve reflex connected the heart and the lung may cause additional problems as a diseased heart. Mucosal irritation in the form of acute or chronic bronchitis, nasal tickle, or conjunctivitis is characteristic of higher level of air pollution. Also, individuals vary considerably in their susceptibility to such effect. Eye irritation is particularly severe in the setting of high level of particulates, which need to be in the reparable range described and may be quite large subparticles, or of high concentration of photochemical oxidants and especially aldehydes. The link between cancer associated with the organic contents of air pollution has always been a concern, but an association has not been proven for ambient urban air pollution of the types described. There is little evidence to suggest that community air pollution is a significant cause of cancer except in unusual and extreme causes. Central nervous system effect and possibility learning disability in children may result from accumulated body burns of lead. Air pollution contributes a large fraction of exposure in many countries because of lead additives in gasoline. Even in countries where lead has been removed from gasoline, the lead remains in the environment as one source of exposure. There are several documented occurrences in which severe mortality from many causes is associated with short-term exposure to fine particles. Air pollution has been associated in several episodes of high mortality, usually among persons with pulmonary or cardiovascular disorders. Recent studies have shown an association between particulate in urban air pollution and mortality from a wide variety of causes, not just lung disease. This finding was unexpected as the levels studied were much lower than those had been previously linked to increased mortality. The reason for the never findings is probably that the method of statistically and analyzing large populations are much better and the method of measuring exposure are much more refined than those used earlier.
What causes 1 in 9 deaths worldwide? Affects 80% of people living in cities, but is often invisible. What leads to more than a quarter of deaths from heart disease, 34% of deaths from stroke, and kills almost as many people each year as the number of breaths you take? The answer: air pollution. Air pollution is the single greatest environmental health risk we face. It threatens our bodies, our climate, and our future. There are simple solutions to cleaning our air and cooling our planet. Let's tackle this global health crisis together in order to protect our planet and ensure a healthy future for all. Join us in breathing life back into our cities.
Air pollution episodes. Hopal gas tragedy. The poisonous gas methyl isocyanine leakage in the pesticide manufacturing plant of Union Carbide of India, Bhopal, Madhya Pradesh, on December 3, 1984, 46 tons of methyl isocyanine was released, spreading to 40 kilometers. Effect: about 65,000 people suffered from various disorders in eyes, lung, stomach, heart. The immediate symptom in bronchospasm, which caused coughing, chest pain, and abdominal pain. Nearly 3,000 people died within a short span of time. 1,600 domestic animals died and crop yields were reduced. Next example, darkening effect of Taj Mahal. Taj Mahal is a white marble stone mausoleum. Recently it was observed that the walls of Taj Mahal has become darkened and disfigured due to air pollution from nearby Mathura oil refinery. The acid rain reacts with marble stone to produce calcium sulfate, causing darkening and disfigurement. London fog. On December 5, 1952, a phenomenon known as a temperature inversion occurred in the atmosphere in London, England. This resulted in a dense fog forming in the center of the city. During a temperature inversion, very little air movement occurs, and air including the particulate matter and other pollutants it contains gets trapped in a given location. Suspended matter in the air can provide nuclei on which particles of moisture and other pollutants, such as acids, are deposited. During this time, the temperature hovered around zero. The burning of fossil fuels, coal, in open hearth fires in homes, in the industrial generation of electricity, and the emission from transportation vessels contribute to the atmospheric pollution. Measurements for total suspended particulate matter and sulfuric dioxide were routinely made in both central and peripheral London during this time. During December 6, 8, 1952, daily average from all monitoring points increased about fivefold to 1.6 mg/m3. Peak value were times the normal value and were higher in central London. In comparison, the mean December 1987 concentration for total suspended particulate matter was in the range of 0.12 to 0.44 mg/m3. The demand for hospital beds increased on December 8, and the Central London Hospital issued an emergency bed warming, but we had sufficient beds for fewer than 85% of applicants. The mortality rate in certain parts of London increased dramatically during this time. The major cause of this were a variety of respiratory-related illness, cardiac illness, and ill-defined illness. At least a few deaths were caused by injuries and a few people drowned when they could not see and fell into the Thames River. In addition, many animals, cattle, had to be slaughtered because of illness during this time, likely because of the fog. Based on the epidemiological data collected during the London smoke episodes, it was felt at the time that the increased number of deaths in London during the fog was more closely related to the particulate matter in the air rather than the sulfur dioxide. Early analysis later thought suggested that the acid aerosol, sulfur dioxide, were the major factor in causing the increased mortality. Sanitary bacteriological parameter of the atmosphere air. This is biological property of atmosphere air and dependent on microorganisms and viruses in air. The different microorganisms are present in the air. Some of them, as bacteria and viruses, have the most hygienic interest. Transport of the bacterial pathogen in the host. Direct contact and indirect contact. Direct, coughing, sneezing, body contact. Indirect contact, viscous, by soil, water, food, and others. The atmosphere air is not a favorable environment for vital function of microorganisms. Therefore, getting to the air, they are rapidly eliminated because drying lack of nutrient condition and bactericidal effect of UV radiation of the sun. The bacteria in the atmosphere are saprophytes, which are characterized by higher resistance in environment than pathogenic microbes. There are significant amounts of microbes in the air of closed, insufficiently ventilated, and overcrowded premises. They can be also pathogenic. The pathogenic agents of viruses disease, for example, flu, measles, chickenpox, bacterial disease, whooping cough, scarlatina, tuberculosis, diphtheria, and other infection disease, which can have even mass epidemic character. Researcher Lashenkov revealed two ways of infection transfer through air drop ways and air dust. Air drop ways. The infection happens as a result of inhalation of smallest drops of the saliva, sputum, and phlegm, expirated by patient or by illness carried during of cough, sneezing, and even through speaking. It's now that the smallest drops can be sprayed on distance from 1 up to 1.5 meter and can keep available in suspended state up to 1 hour. This way is the more dangerous in epidemiological sense. All epidemic infections are spread by these ways. Next ways, air dust way. These ways, the infection happens through the suspended dust in the air. The dust contains pathogenic microorganisms. Their virulence is a weakening dye to drag the infected drops of patients' externals. Dust particles with the microbes on their surface can be kept as bacterial aerosol during from several minutes till 2 to 4 hours. There is a direct relation between dust concentration and microbes quantity. So the more dust, the richer microflora. Therefore, the control of dust concentration in premises at the same time is the control and prevention of bacterial pollution of the air. It's especially important to control air pollution in surgical and pediatric department of hospitals and maternity hospital, where an incident of hospital infection are very dangerously. The main attention there should be focused on determination of pathogenic staphylococcus and other pathogenic bacteria which can induce post-operative and postnatal infection and newborn disease. For estimation of the air, the pathogenic hemolytic staphylococcus are determined as indicative microorganism. The The air is considered pure if the bacteria amongst is no more than 1,500 in 1 cube meter in summer and 400,500 in 1 cube meter in winter. Example of short information about disease transmitted by air. Diphtheria. Corynebacterium diphtheria. Gram-positive bacterium that is very resistant to the effect of drying. Usually affect poor people living in crowded condition. Exotoxin can also be absorbed into the circulatory system and cause organ tissue damage by inhibiting protein synthesis. Symptoms include nasal discharge, fever, cough, formation of pseudomembrane in throat. Diagnosis is made by observation of pseudomembrane and bacterial culture. Prevention is by active immunization. Next disease, meningitis. Meningitis, inflammation of brain or spinal cord, meninges, caused by a variety of organisms and condition bacterial septic meningitis. Transmitted by inhalation or respiratory secretion from carriers or active causes. Symptoms include initial respiratory illness or sore throat interrupted by one of the following: vomiting, headache, lethargy, confusion, and stiffness in the neck and back. Tuberculosis. 1 billion causes worldwide, 20% of Earth's population. 10 million new causes each year, 3 million deaths per year. Human-to-human transmission by direct, nuclear, and foodborne transmission. The disease usually stops, but the bacterium remains alive. Preventive measures of the air infection transfer are the elementary behavioral rules at cough and sneeze. To close a nose and mouth by handkerchief and turn aside from people. To carry gauze mask by people during epidemic. Maintenance of premises cleanliness by regular damp cleaning. Maintenance of established norm of the space and capacity of premises and public building. Sanitation of the air of hospital premises with the help of disinfectant and bactericidal lamp. Modern ecological problem today: transborder air pollution, acid rains, greenhouse effect, ozone gaps, smoke, and others. The chemical composition of a global troposphere, the lowest 10-50 km of the atmosphere, is changing. Various trace gases that are chemically inert in the troposphere, greenhouse gases, such as nitrous oxide, fluorocarbons, as well as some more reactive compounds such as methane, carbon monoxide, ozone, show a strong increase in concentration. This is associated with the possibility of the global warming. The absorbed depletion of the ozone layer in the stratosphere during recent decades is a truly global air pollution problem. It's now evident that the principal cause of the substantial increase in industrially produced chlorofluorocarbons and halogens that have found their way to the stratosphere. Owing to their long life, they are expected to cause ozone depletion until at least 2100. Another important large-scale change is the decline in the self-cleaning ability of the troposphere, directly lowering the level of hydroxyl radical as a result of an increase of methane and carbon monoxide emission. Although these radicals are present in a very small concentration in the atmosphere, hydroxyl reacts with virtually all trace gases, including the conversion that would otherwise be inert. If concentration of hydroxyl decreases, trace gases which have a longer atmospheric lifetime and thus increase in concentration. These include greenhouse gases such as methane and substitute for chlorofluorocarbons such as hydroxyfluorocarbons. could reach the stratosphere and replace ozone. Although the population represents only about 15% of the world's population, its nations contribute a larger percentage of the greenhouse and ozone-depleting gases, 30% of carbon dioxide and 36% of chlorofluorocarbons. At the same time, global air pollution problem may greatly affect the 8,050 million inhabitants. The combined problem of global warming, stratospheric ozone depletion, and increased tropospheric pollution may have important implications for human health. The magnitude of this effect will be determined to a considerable degree by energy policies and the control of emission of greenhouse gases and chlorofluorocarbons. Ozone depletion on the Earth. The major concern with the depletion of the stratospheric ozone layer by chlorofluorocarbons is when more ultraviolet radiation from the sun penetrates to the Earth's surface. As a consequence, increase in skin cancer, non-melanoma, and malignant melanoma may be expected, as well as possible increase in eye disease, primary cataract. There may also be alteration in the immune response. It has been estimated that for 1% of depletion in stratospheric ozone, non-melanoma skin cancer can be expected to increase by about 3%. This protection does not take account of any protective measures that might be adopted. The country of the Euro, along with many others, have recognized the potentially harmful effect of chlorofluorocarbon and halogens on human health and the environment, and two protocols have been drawn up within the framework of the United Nations Environment Programme. The 1985 Vienna Convention for the Protection of the Ozone Layer and the 1987 Montreal Protocol on substances that deplete the ozone layer. More than 60 countries have now signed the Montreal Protocol, including those in the European Union and most Eastern European countries. Also, the protocol calls for a reduction of chlorofluorocarbon production to 50% of the 1986 level by the year 1999. It ignores the fact that the chlorofluorocarbon destruction rate in the atmosphere is only 15% of the 1986 production rate. Ozone depletion would therefore continue even if the Montreal Protocol were fully implemented. It was therefore amended in London in 1990 to incorporate a complete termination of chlorofluorocarbons and balloon emission by the year 2000 and ban on carbon tetrachloride and methyl chloroform before 2000 and 2005, respectively, photosynthesis in the food chain by increasing levels of ultraviolet radiation. Acid deposition. Acid deposition has been recognized for over 2 decades in the European, mainly as a threat to the natural environment. This recognition has resulted in major research programs and important political commitments to reduce precursor emission of sulfur and nitrogen. As mentioned, the implementation of a sulfur dioxide protocol significantly decreased emission in the region by 28% on average, and the resulting deposition has also declined. The major human health effect concern related to acidification and the mobilization of heavy metal. First, lead and copper may be leached from the piping of municipal water supply system and ingested via drinking water. Second, cadmium and mercury might be mobilized from acidic soils and reach humus via bioaccumulation in the food chain. Effect of acid deposition declining aquatic animal population, then shield ice, prevent bird reproduction because calcium is unavailable in acidic soil forest decline. To set budgets for the control of air pollution, it is necessary to set standards or guidelines. The standard implies a set of law or regulation that limit allowable emissions or that do not permit degradation, deterioration of air quality beyond a certain limit. The guidelines implies a set of recommended levels against which to compare air quality from one region to another over time. Standards may take two forms: ambient air quality standard and emission standard. Ambient air quality is the general quality of outdoor air in the region. Guidelines are usually for ambient air quality only. Emission standards set the amount of pollution that is allowed to come from a particular source. Ambient air quality standard or guidelines, a level of general air quality means that not only should air pollution not exceed certain level, but it cannot be permitted, on average, to get worse over time even within the allowable level. Control of emission at each source is the key to managing air quality, but transportation policy, energy policy, such as the choice of fuels and setting of facilities that may emit pollution all play a critical role. A major element in the success of air pollution control is the degree of authority that can be exerted by the government agency that has this responsibility. The ability to close or shut down a plant is the ultimate tool for enforcement agents, but the ability to fine, bring lawsuits, and prosecute offenders is just as important. Often just the threat of such action motivates the management of a plant to cooperate and correct the problem. Emission standard rules about how much pollution a particular source may emit to the atmosphere require periodic inspection and regular monitoring to be effective. These are generally easier to enforce for stationary sources where equipment can be set up on a permanent basis and the pollution control apparatus can be inspected directly. The source or facility may require a permit from the government to operate or may be required to register and to provide regular reports on the pollution it has generated. Generally, emission standards for individual factories, power plants, or other stationary sources allocate an allowable level of emission based on their past performance and share of contribution to the regional airshed. We must not exceed this allowable level of emission or we will receive a citation and must pay a fine. In practice, the fine must be high enough to deter violation and not be just another cost of doing business. Where repeat violators, where permit to operate can be suspended if the law allows. In some jurisdictions, the entire plant is considered a single source for purpose of regulation. If engineers can reduce emission in one part of the plant, we are allowed to build new facilities that increase emission in another part or to build a new addition to the plant that might generate new emission. The overall level of emission from the entire plant must not increase. However, this is called the bubble concept because the plant is thought of being enclosed in a bubble in the air quality and the bubble cannot be allowed to deteriorate. Mobile sources are more difficult to monitor. However, and many jurisdictions require regular vessel inspection to ensure that emissions from each truck or automobile are within acceptable limits. To effectively manage air quality in an urban region, an administrative mechanism must be set up that includes trained inspectors and technical staff who can operate the complicated equipment needed for air quality monitoring and who can interpret the resulting. A permitting or registration system is needed for enforcing emission standards. Public education should be very much a part of the duties of staff and should enforcement and monitoring. Many air quality agencies are operated separately from public health agencies, which are often attached to environment departments of government. Ideally, these agencies have the authority to meet with plant owners or managers before facilities are even built to avoid problems before they occur. The next measures of air protection are use: legislative, layout, technological, and sanitary. The legislative measures include law and regulation for air and environment protection, elaboration of normative material, maximum concentration limit of injurious chemical substance. Technological measures: substitution of some kind of fuel by other more safe for environment, gasification, and electrification. The layout measures include zoning of settlements, territory taking into account a windrows, accomplishment of settlements for dust pollution prevention, for example, planting of trees and gardens, observance of sanitary protective zone, control area. The sanitary measures include treating plants to decrease of injurious impurity of emission in industry enterprises. Sanitary protective zone. Sanitary protective zone of industry enterprises is a territory or sanitary space gap between emission source and the border of the nearest residential area. Is intended for maintains all required hygienic norm of polluting substance concentration in atmosphere, creation of architecture, aesthetic barrier between industrial and residential zone, organization of additional areas for greenery planting. Size of sanitary protection zone depends on enterprise's hazardous class and include distance 50, 100, 3, 500 and 1000 meter. Thank for attention.